what's the hull speed of a boat that has a length of 16 feet at the waterline. So they're giving us R, and they're giving it to us in the units that work for this equation. So now we just plug it into the equation. We don't know S, but we do know R, so we can write that equation. And now it's just a matter of working out order of operations. Square root of 16, what number times itself gives me 16? 4. So square root of 16 is 4, and we rewrite everything else the same. And then just use our calculators to do 1.34 times 4. So S equals 5.36, and we need to interpret that in terms of the problem. What's the hull speed? The hull speed is 5.36 knots, right? Now they want us to write an equation you can use to determine the length of the boat if you know the hull speed. So this is sort of opposite. Here we know S. So we plug S in, so 6.7 equals 1.34, but this time we don't know R. We don't know what R is, right? So here's the equation, and that's all they asked us to do. They didn't ask us to find the length of the boat. They just asked us to write an equation, and we've done that. So we can move on to the next problem. 3, transform your equation you wrote to isolate the radical on the side of the equation. So let's rewrite this. 6.7 equals 1.34 square root of R, and they want us to isolate this. So isolating it means undo everything that's happening to it. The only thing that's happening to it is that we're multiplying by 1.35. So we divide by 1.35 on this side, and that'll get rid of that. But what you do to one side, you have to do to the other. And we'll use our calculator. 6.7 divided by 1.35 equals, and here, 1.35. We have a fraction. Oh, you know, I used the wrong number, sorry. This should have been 1.34. I copied wrong, so let's change this. 1.34, 1.34, 1.34. Okay, sorry about that. 6.7 divided by 1.34 is 5. That's easier to work with. Here we would have had a round, but the problem made it nice for us. So 5 equals the square root of R. Right? So they wanted us to transform the equation to isolate the radical. And so we've done that. Again, they still haven't asked us what that length is. They just wanted us to isolate the radical. Now they want to know what the length of the boat is at the waterline. So the question is, what number, when you square root it, will give you 5? Or another way to talk about it is what can I square 5 and get, right? What number, when I square root it, do I get 5? Well, that's 25, right? 25, square root of 25 equals 5. So how do I know? Because 5 squared equals 25, or square root of 25 equals 5. So 25, and you have to, again, interpret it. R is in terms of feet. So 25 feet. And don't forget to explain how you know. Now, number 5 is trying to talk you through this idea we're coming up on. We've been working with radicals, these square roots, right? Square roots, cube roots, fourth roots. There's a different way to write them. So number 5 is trying to talk you through this new way. So you're about to learn a new way to write radicals, and this is trying to talk you through. So you know that R equals 25. That's given. Now they want you to write 25 as a power. So 25 as a power, 5 squared is the same thing as 25, right? So that's a power. Then they want you to substitute square root of R for 5. So we need to substitute. That means take the 5 out, put square root of R in. Take the 5 out, put square root of R in, and then rewrite everything else the same. Okay, so now they're going to talk us through this new idea of how to write square roots. So you can write the equation of the length of the boat this way, right? R to the first power equals the square root of R squared, right? And you know that when you have a power of a power, you multiply the exponents. So they're saying that the square root of r must be the same thing as the square root of r to the 1/2. Because if you take square root of r out of here and write r to the 1/2 in there, then 1/2 times 2 equals 1, and you end up with the same thing. So basically they're introducing you to the idea and showing you why. That you can rewrite radicals as fractional exponents. So a square root symbol is the square root of r is the same thing as r to the 1/2. And if you extend it, they're telling you anytime you want to do that, you can rewrite a radical. So like the third root of r, cube root of r is the same thing as r to the 1/3. The fourth root of r is the same thing as r to the 1/4. So this is just a new way to write the same idea we've already been working with. It's a notation thing. And this was trying to show you why it's consistent with everything we learned about exponents before. And down here, they just want you to practice it. So rewrite each radical as a power. The cube root of 7 is the same thing as 7 to the 3rd, right? The fifth root of x is the same thing as x to the 1/5. Now you do this one. And here they wanted you to go to radical to exponent. Now they want you to go the other way. 8 to the 1/4 is the same thing as the 4th root of 8. Z to the 1/5 is the same thing as the 5th root of z. You go ahead and do C by yourself. Now they want you to write the equation for the whole speed of a boat using a rational exponent. Rational meaning like a fraction, right? So before we learned the whole speed of a boat, they told us back here, this was the equation and they used a radical. Now they want you to use an exponent that's fractional, right? So s equals 1.34 times the square root of r could also be written, we just need to change this to a fractional exponent. S equals 1.34 times r to the 1/2. We rewrote the equation using a rational exponent. Okay. Another equation can be used to determine the speed of sailboat in knots. And this equation is S equals A over D to the 2/3, where A represents the sail area and D is the boat's displacement. So instead of talking about the speed in terms of the length of the hull, we're talking about speed in terms of sail area and boat's displacement. And notice they have this fractional exponent, this rational exponent, but it's not just a 1/3, it's a 2/3. So we need to kind of figure out what does it mean. Clearly, if there's a third, we're talking cube roots, but what does this mean that there's this 2 in the denominator, in the numerator? So they're going to tell us what that means. And if you read through, you'll notice that this is the same thing as talking about d to the 1/3 times 2, right? You can separate those two parts. And we know that d to the 1/3 is the same thing as the cube root of d. So basically, we're just squaring the cube root of d. Okay? So we're combining a lot of things we know about exponents and radicals to kind of understand this new notation. So now we're going to use the equation to calculate the speed s of a boat that has a sail area of 600 square feet, displacement of 125 cubic feet. So we know here that A is equal to 600. We know that D is equal to 125. And notice they didn't tell us for sure what the units were supposed to be up here. So we're going to assume the units are good. We're going to assume the units are the way they need to be for this formula to work out. They really should have given us the units at the beginning. So now we can just use this. We can plug in. We know that S equals A over D to the 2/3, right? Or we can think of this the same thing as the cube root of D squared. I think that's an easier idea for me to handle. Cube root of d squared. So now I just plug this into the formula. 600 over the cube root of 125, and then I'm going to square that. Now it's just order of operations. So I leave 600 alone, but I need to take the cube root of 125, and remember we already learned that that was 5. We already worked that out for ourselves. So this is cube root of 125 is 5, but we still need to square it. And 600 stays the same. So squaring 5 means 25. And then 600 divided by 25 is 24. So the speed of the sailboat, now they did give us the units for speed. It's in knots. So the speed of the sailboat is 24 knots. Now down here they want us to write each expression in radical form, show your work, and simplify your answer. Okay, so write each expression in radical form. So 4 to the 3 halves. Now we know that having a half means we're taking the square root, right? But then we still have this numerator, so that means take the whole thing to the 3rd power. So we wrote each expression in radical form. Now we need to simplify our answer if possible, and it is possible. Square root of 4 is 2, and then we have still 2 to the 3rd, which is 8, okay? Now I'm going to do C. I want you to do B by yourself, but I'm going to do C, okay? Here, again, we know that when you have a fractional exponent, a rational exponent, the number in the denominator is the kind of root you have. So I have the 5th root of x. Here, this stays still the base, but then I still have the numerator, so I need to raise the whole thing to the 4th power. So I wrote this expression in radical form. Now, can I simplify my answer? No, because I can't do anything more with this x. I can't take the 5th root of x, so this is the answer here. And last part of this part 1 of independent study is to write each expression in rational exponent form. So we're just working the other way now. Show your work and simplify your answer if possible. Okay, so again, if we have the 4th root of 2, we know we're going to have a fractional exponent with 4 as the denominator. But here we have a numerator, so we know that 2 is going to be the base. 2 will be the base, and we need a fractional exponent with 4 in the denominator. But now we know the 3 is in the numerator. And we need to simplify this if possible. So it is possible. We know that we can take 2 to the 3rd power, and that's 8. But the only thing is that the 4th root of 2 is an irrational number. So when it says simplify the answer if possible, I want you to notice something. I went ahead in my calculator and raised 2 to the 3/4 power, right? I can do that, 2 to the 3/4 power. And I just used my division sign to create that fraction bar and hit enter. Now, whenever you see a number like this and you're dealing with roots and it goes to the end of the screen, you can pretty much assume it's going to go on forever and ever and ever. That means it's an irrational number. So when it says simplify your answer if possible, it really isn't possible to simplify this because it's an irrational number. So we are going to leave this the way it is. This fraction is simplified, and 2 to the 1/4 is an irrational number. So we'll leave that as it is. I want you to go ahead and do B on your own. And then here we're going to rewrite this. So rewrite the radical with a rational exponent form. So again, x is going to be the base. We know we're going to have a fractional exponent or a rational exponent. We know that 5 is going to be in the denominator and that 8 is going to be in the numerator. And we can't reduce this fraction, so we're finished. Go ahead and do this one. And please look to see if you can reduce the fraction, because if you can reduce the fraction,